So now that we've learned about work and we know that work is equivalent to energy, I'm going to talk about some different kinds of mechanical energy in the next few videos and how to calculate the energy that an object has. So I'm going to go over several types. We're going to talk about kinetic energy, gravitational potential energy, and elastic potential energy. And I'm actually going to start with gravitational potential energy, or GPE. Potential energy also, just in general, because there's lots of different types of potential energy, sometimes is written with the letter U. So, in order to lift an object up off the ground, you need to apply work or do work on that object. And so we must be adding energy to that object. And the energy is stored in the object due to the fact that it wants to fall to the ground, or it has the potential to fall to the ground. And so this kind of stored energy as a result of lifting something above the surface of the earth or some relative lower position is called gravitational potential energy. So remember that we said that work is equal to energy. So if we want to calculate the amount of work or the amount of energy we've added to the object, we would calculate the change in energy. So if you see here, we have mg, and then this is the change in the height. Instantaneous gravitational potential energy, to calculate what energy something has just at that moment, is just mgh. And if you notice, remember that work is force times distance. Well, we know that by lifting something up off the ground, we're overcoming the force due to gravity, which is mg. And in this case, the distance that we're moving something is a height. So that's where this equation comes from, mgh being force times distance. So we can calculate the gravitational potential energy at any instant, or we can calculate the work or the change in energy in an object by calculating the difference between the two heights. Now let's go ahead and just look at a couple of example problems. Right? So let's say that we have a roller coaster, and the roller coaster is 30 meters up at the top. You've got a car, right? And let's say that car is 500 kilograms with people and the car itself. And we are 30 meters above the ground. Well, that roller coaster eventually is going to want to go down the hill, right? But as being up here at the top, it has some stored gravitational potential energy, which is equal to mgh. So in order to calculate that, we would just take 500 times 10 times 30, and let's see what we would get. So that would be 1.5 times 10 to the 5. So 1.5 times 10 to the 5th joules. Alright? So that is gravitational potential energy at that moment. Now, let's say that it was to drop and now be at a height of only 20 meters. So now my car has started to go down the hill, and it's at a height of only 20 meters now. Well, we could figure out the gravitational potential energy at that instant too by doing 500 times 10 times 20. So 500 times 10 times 20 gives us 1 times 10 to the 5th joules. Okay, so it has lost some of that energy, and we'll learn in later videos where the energy is gone, because we know energy is conserved. Now, the other type of question that you could be asked is, what is the change in gravitational potential energy, which also could be called work, right? And that would just be the difference between these two, right, going from here to here. So that's a real easy problem to solve. We would just say it's 0.5 times 10 to the 5th joules. Okay, so these are all different ways that we could be asked this problem. We could be asked instantaneous gravitational potential energy at any moment, or we could be asked change in gravitational potential energy.